Hello, everyone who's joining our webinar today. This is Christopher Adamus here. So welcome here and hope you will enjoy and get valuable insights from our professionals. So Christopher, your turn.
Hello, everyone, and welcome to this webinar. Today I will show you few options on designing a hybrid framework on an implant bar for AllonX restorations. There are quite a few things to know, and there's a few methods to do it with 3Shape software. So I'll try to explain you how this can be done and how to obtain a good results relatively easy. Also, what to look for during the design to make it as smooth as possible. So the ones that haven't had a chance to meet you, my name is Christopher Adamus. I'm a dental technician and training and education manager for 3Shape. I've started in 3Shape 14 years ago, actually. And prior to that, I worked in a milling center in UK for 5 years, where I've started working on 3Shape solutions back in 2007. And I have a few things on the agenda. So I'll start with control panel setup. There are a few things that every user needs to go through, and there's one thing that I wanted to show you because I get the questions about those things relatively frequently, and I think it's very much an overlooked option. So we will start with something that, regardless if you're basic or advanced, you need to do. And then I will move towards the bar design. There are two bar designs that can be done. I will start with the one that I'm getting more questions about because the second one is really rather easy. So there's really no mystery over there. And then we have two secondary designs, and those, like I said, can be done in. So we have one based on the RPD module, which is really, let's say, well established and known for quite a long time. And the second one, which is with the use of a denture module. This one is newer, but since denture module is growing and being developed, let's say, very actively throughout the last few years, that is the alternative module. And both of them, they have some pros and cons to them. I will try to emphasize them. And at the end, we will try to look into a Q&A. So if you will have some questions, you're very welcome to ask them, preferably in writing. There should be a chat or a question section where you can submit your questions. And then at the end of the presentation, we will look into them and try to answer on some of the most popular questions, or the ones that will be the most relevant. Right. So without further ado, I will start with at the beginning. I've made a short recording of things like this, just so I can speed some of the things up. So first things is the control panel. And one of the things that I always recommend, especially when we're going to be dealing with bigger cases, is to check for the latest implant libraries. So if we'll go to the download center on the left side and go through download libraries, within a couple of seconds, the list will be populated, and there's a lot of implant libraries available. A small trick to filter only the implant libraries: if you click on this light blue bar, it will hold an extra option where you can search specifically for implant libraries. And the black ones are the ones that you can just click and download on a request. The gray ones usually require additional request to the support. And then they can be downloaded. And of course, they can be found in implant systems over there on this list. I'm going to be using the standard one, not to be biased. And it's only, let's say, test cases that I'm going to be showing you today, but the mechanics are the same. Second part is the bar option. And in here, of course, we have a different implant bar components. Some of them I already played with and made a copies and make some modifications, and that's what I'm going to do right now. So I took a primary 2-degree tapered bar. I'm going also moving it to the top of the list. I'm going to be using, let's say, frequently on this occasion. I also changed the style by default to be wraparound, and then clicking on this preview button, I do get to the cross section defined white with those reference points. I also clicked off snap to grid, so I have a full freeform of movement of those points. And that's what I'm referring to as one of the most frequently asked questions. How to modify the shape of the bar. How can I get the shape of the bar with a slight chamfer? So that is something that I did in basically 5 minutes. And you can see that when the option snap to grid is enabled, it only moves to the corner through the corners. But when it's a free form, then we can place the points wherever we like. Of course, we can make corrections and preview how it's going to look afterwards. Right now, the chamfer looks okay. We have the upper corner also smoothened up, and of course you cannot forget about saving the changes that you're making. That's gonna save both changes in the abutment section, but that change in the bar design that we've just made. Okay, the next option will be to, of course, to the next slide. And here I will just start with creating the order form. And creating order form for the bar is one of the easiest things that you can do. We need to define which components we are going to be working with. If we're going to be making a scan, of course, we'll be making a scan. If we will be importing the scan, it will work in a similar way. I'll pause in here for a second. Because in here, since in my case, I do have a model scan, I will change it to introller scan, only because I will need to place the model. And after setting it up, I've selected the first option in here, which is the abutment. And then in the bridge section, second option that you can see, this is the implant bar, where I can also choose right now. Of course, it's possible to modify it in the design, but I can already in here select what type of shape I would like to use from the get-go. And I'm also making sure that my implant kit is set for bar component. And once those are selected, then I will change the model to a digital impression, so I can actually select also model for production. You might ask why the model will be necessary. In here, I need to think a few steps ahead. Designing the secondary structure is going to be made through either RPD or dental module, and those modules prefer to have a base to the scan. So the model shouldn't be watertight. Well, it should be watertight. So we need to give it a little bit of a base. For implant bar option, that's not necessary. That's why I chose deliberately to make an intraocular scan, although the scan that you will see will be a model. So software will take it as an option, purely for me to be able to set up that it is going to be a model. So we will create a base for this case. And then, of course, if we have a model to scan, we can scan it. In this case, I do have a scan porting. So you need to do it, of course, in the correct order and with the right annotations. If the scans will be coming from the trios, usually the order form will be already filled out for the correct indication. Of course, it can be modified, but most importantly is that it is also a watertight model, so it needs to have a base. Then going through the first stages, We can, of course, refine the scan. If it is an intraoral scan, software will be going through this stage as well. And then we can set up the occlusal plane. The way I like to set up the occlusal plane is, in this case, I can match it to the antagonists and then lift it up a little bit higher. That will give me a good estimation for the bar that I'm going to be designing. Then, of course, trimming the part of the model that it's not going to be necessary. Since we're going to be building a base for it to make it watertight, it doesn't have to be really all that long. That looks pretty reasonable. Now it's time to do the same for the antagonist. In my case, I do have antagonist what looks like a there. It also might be some sort of a hybrid case, but this one looks quite wide, so it's probably a natural, full-size denture that probably in the future will be replaced. So again, this one doesn't need the whole base. We will be creating it separately. So it's easy to trim it. And then, of course, we have an option to do some sculpting. In here, I have a little bit of imperfection on the model. So I used an option to remove an artifact, and that looks okay. Normally, there's one more stage that would happen in this case. If we have, right over here. So one more thing that I wanted to mention is that for a case like this, if it would be coming as an intraoral scan, we would also have to match the scan bodies to the scan. And this would be the stage where it would normally happen after sculpting. That's where it would be. In this case, since this model, like I said, was scanned in the laboratory scanner, the information about the implant is already in the scan that I have imported. That's the only reason. Oh, sorry. That's the only reason why software didn't ask me about the alignment between the scan bodies. They are still there, but since they are already embodied in the model, it's not happening over here. If it's an intraoral scan, that is the process that you will still have to go through. And that's, I would say, one of the differences that you would expect if it would be a real intraoral scan case. So since the implants are already there in here with the new software, the annotations are being given with the use of the AI algorithms. So this one is already preset. Then, of course, we need to define the insertion direction for the case, and that will give a shape or the direction for the implant bar. So initially, it is set up according to the insertion direction. And as you can see, because I have selected my modified 2-degree tapered wall, that's where the software placed it automatically. It comes already in the model and spreading across the arch across the implants. Now there's an option to show the occlusal planes enabled, and like I showed you earlier on, in this case I've set it up from the antagonist case. I lifted it up to give myself some space for the secondary restoration, and clicking on one of the control points, I selected option to lift the bar to the occlusal plane. And now it looks like it's almost entirely flat, and that would ensure that there will be some insertion path for the secondary structure. Of course, some of it will be protruding through the gingiva. So having a couple of control points, I can adjust it to the correct height. It's also possible later on to cut it to the gingiva in a few areas. What you will also see in here is that each of the about is being clicked on, and there's options to use insertion direction and adapt to the height of the bar. So now all of the implants, they are going to be parallel with the insertion direction of the bar. And I will basically set my bar in a way that it's going to be, of course, in contact with my implant elements, but it will also provide a good support around, keeping in mind also screw holes. With the use of the shift button, control points can be grouped, so they can be moved, let's say, as a one group all at the same time. What you will see right now is that there will be more control points. In this case, since we have a pretty thick bar, the abutments can be lowered to make sure that they are not going to collide with the shape of the bar. And I usually like to add a couple of extra control points to be able to shape the bar in a little bit more natural shape to support the right, but also not to make it too thick. And of course, because the elements between the control points are straight, I've added one at the incisive papilla to give it a little bit nicer arch. Of course, the components can be then stretched and adjusted to make a more homogeneous design. Yeah, afterwards, like I said, it could be also adapted to the bar, but that's going to be on the sculpt toolkit. So the reason why I've put this as a part of the video is so I can explain what's happening without, let's say, wasting too much time in the process. So once this part is done, I will also check that, like I said, components are not poking through, because that might cause the areas for where additional thickness will be needed, or drill compensation if we're going to be milling the secondary structure here. Like you said, there is a little bit of a protrusion on the other side. In here, I will pause for a second because there's a little bit of a morphing tool that I used to bring back some of the gingiva to some of the bar closer to the gingiva. And then afterwards, there's a icon with precise cut tools at the very end, where you can define the distance to the gingiva and basically cut the bar to make sure that it's not going to be colliding, it's not going to be protruding with the shape of the bar. And once this part is being done, then the elements are being connected together. And in here, I will pause for a second. What happened in here is, right now, I know that I will be using this design to use it for RPD design that will go on top of it. If I will be designing a denture module, then there's 3 scans that are required for denture design. It's the upper jaw, the lower jaw, and the wax. Naturally, from this case, there's no wax rim information, but I can create it by, let's say, creating a customized file. In this case, I will take my preparation scan, my bar design, and antagonist, and choosing this purple tooth icon with additional scans, I will select the option save, and then with the use of the control button, I will click all of the elements that I would like to add to this file. In this case, like I said, prep, bar, and antagonist. And that will naturally create, and I can save it as a one object in a DCM format with the correct orientation in 3D. So you can see all of them has been created. I will save the model, and I will save it on the desktop name it wax rim. Oop. Sorry, go back for a sec. We've been find it in a moment. Yeah. So I'm calling the file wax rim with capital W and capital R, and that's going to be saved as a DCM file. And I'll keep it somewhere on the desktop so I can use it for my secondary structure, just add scan to determine the occlusal plane for the denture. And once this model is saved, I can continue with the rest of the design. The bar will be saved. And the next natural step in this process will be to go through the model builder. Naturally, we already trimmed the scans, and now this part is also important, so I'll pause for a second. Creating a model for a secondary structure can be done in a few ways. So we can create a model by copying and appending design to the preparation. I'll show you later on where to find it in the software. But since I'm already in the model builder and I'm going to be creating the base, one of the options that we have in the model builder is option to either cut the gingiva with the design or merge the design with the model. So I'm just going to simply select merge all of the designs with the model. And if you'll see later, that will become an integral part of the model, and it's going to be ready for copying. So that's how it's going to look like. And then if we're going to go later to have the either ID tag or the correct height of the model, because at this point, it's not going to be necessary for my design. Of course, if you will be printing it and trying it out, then it's good to have some sort of articulator interface there. For my simple design, it's not going to be necessary. And now all of the models has been saved. Video is a bit jumping here. So once it's saved, now this model, I'll pause for a second. In here, what's important is that we have an option to make a copy. And of course, we can append the CAD design to preparation. I do it just in case to make sure that everything is in the right order. And that naturally creates a duplicate with the order, with already the scans imported. So you can see that software will open the order form in exact same shape and form as it was earlier on. But right now, I can modify it to my secondary structure needs. So I'll delete what was there before, and we have few options to select what is going to happen there. If we will be designing the denture, then of course we need the gingiva and artificial teeth. And we can create a secondary structure like this. In here, the easiest will be to use the monoblock option, because it will create a monolithic object with a gingiva and the teeth. And the fact that in here we have a zirconia as a material, that already suggests that, yes, it could be saved and potentially used for a zirconia if your primary framework will be made out of metal. So that's, let's say, one of the options to do it. But we will have to add the wax rim scan to it. Another option that could be done, since we are on order form, that is to use RPD module. And for RPD module, you can see that we can just mark the outline for the major connector, and that's the one that will be covering our bar. And then we can use artificial teeth to place on top of it. Those, of course, can be merged during the design. The same option that I showed you with saving, to highlight the objects that we would like to keep as one file and save those together. And of course, that will work fine as long as it's going to be a secondary structure that will be made in full contour and then, let's say, stained and glazed. But that's not the only option, because what we can also do is we can use the option for crown pontics. Pontics can be added as an option for RPDs. So that's another option that can be done. Pontics are quite easy scalable, so we could also scale them down if there will be a necessity to finish the secondary structure, either with ceramic, if someone dares to do it, but more likely composite. So in here, it's also a good moment to mention the differences. When it comes to designing using the denture module, we will receive, let's say, a full contour gingiva and full contour teeth. Those will be generated as a one file. So of course, staining and glazing it and adding some colors shouldn't be too much of a problem. One of the big advantages of the denture module is the gingiva tools. They are looking very nice and aesthetic. So that will give a really good results pretty much, say, during the design. If we will be doing the RPD module, of course, we can add anatomical shapes of the teeth quite easily. But the gingiva option, we're going to be using a major connector there. So the gingiva option is not going to be looking as elaborate and might require a couple of minutes of, let's say, waxing up to give it more anatomical shape, but it's also doable. Obviously, if we're going to be using pontics with an intention of fitting it with a composite, then we can use major connector without giving it too much of a shaping, and use the pontics as basically a substructure for the final restoration. In here, I will leave it up to you which option will work, but that would be the main differences in here. I'm not sure which ones you will need. I'm just showing you the tools of what are the possibilities and how to use them according to your needs. So in here, it also says that changing the order might require rescanning. Would you like to rescan? If it's going to be RPD, no. For the denture, rescanning is not really necessary either. We just need to know about the wax room scan that should be added. Otherwise, starting the order is not really going to be possible. All right. So these are the, let's say, the benchmarks, the ground rules that I wanted to set for you. So if I will take away the presentation and go back to the software, I've started with designing some bars earlier today. And I used one just like the one that you have seen in the video just a few moments earlier. So let's wait for a couple of seconds to load the scan. And this is the bar that has some chamfering. I've made this one a little bit, it's matching a little bit better to the antagonist teeth, and would support them a little bit better in that aspect. And then after this, I use the same module to create a copy and append design to design an RPD on top of this model, and that's the result that I've got out of it. So as you can see, when software makes a copy and append, the screw holes are closed, and that's why we can achieve a nice uniform shape. What I'm going to do is I'm going to click through the option to redesign it and show you how the design like this would look like. And tell you what to look out for. So usually when we import the scan that we have added additional shape, there might be some artifacts. So of course we can refine those. Of course, those might become issues if we would be creating a model, but this one was already created from the primary design, so that's not really something to worry about. Of course, there are some areas on the inside that might be, usually it's the elements in here that you would see that are protruding that could trigger this behavior. The antagonist was loaded from a full model, so that's pretty easy. And just like I was showing you earlier on, I have moved the occlusal plane first to the antagonist teeth, as it's in this case a pretty good benchmark. Then of course we can go through the trimming part, which is not really necessary in here, and sculpting is not necessary either. So I will just quickly jump to the next stage. And as you can see, the element of the bar and the model is considered as one. That's why it's all being covered with a green color. Our software will recalculate the steps in between. Then, of course, apart from the annotations that were from the initial order, there is a necessity to fill the rest of the artificial teeth that will be placed in here. And then we need to find the insertion direction. So I'll click preview to show you what were the results. In here, I've set out the blockout angle to 0 degree. Since we have already 2 degree tapering from the bar, we know that there shouldn't be really much of an undercut. And since all of the chamfer is clearly visible, we will have a pretty fixed resting position for the model. Software will automatically block the undercuts because that's the RPD workflow that we are currently using. The future might bring some changes, so that's what you will see here. And since I had a little bit of a blocking out on the facial side, I removed that. There's also a small spot over here that also can be removed. If I would, let's say, spend an extra 10 seconds finding better insertion direction. Then, of course, we're getting a teeth from the smile composer, which I have adjusted to the shape that I felt comfortable with. And of course, in this stage, it's possible to use all of the sculpt elements. So these are still treated like a regular crown bridge. We can also use a virtual articulator, and I would strongly encourage you to do it to make sure that the case will fit. And there's one more thing that it's worth keeping in mind. After making a setup, after making everything visible and the right areas, I made sure that I left a little bit of a space for my future gingiva element. Probably the posterior region the teeth could be a little bit longer. But let's say it's not going to make us stop finishing this case. But there's one more important aspect. Since we're working with the pontics, unless they are cut to the gingiva, will be left protruding. That's why in the smart tools, in contacts and smoothing, the first option pontics is desired distance to gingiva. And in here, I have set it up for approximately 0.3 of the millimeter, and you will be able to see that all of the pontics has been adjusted to fit the shape of the bar. And that's important because if you're not going to do it, software is not going to cut it. And then your secondary structure naturally will not fit. But even if you forget about it, it's pretty easy to go back and enable this function. Then when it comes to the major connector, we can skip the retention part, and I have just used a simple major connector, drew the outline around my chamfer. I would recommend you to do it a little bit overextended if you are in doubt where to place it, or you will have difficulties finding the exact sharp edge, because it's always easier to make it shorter than longer. Plus the undercuts has been blocked out with 0 degree. So if there will be any, I would call it a skirt, because that's how it's going to look like, then it's very easy to make an adjustment accordingly. First, we will preview the major connector, and this is where it gets important to have the base of the model. You can see that the model in here that it's designed, it is the one that came from the model builder, so it does have a base. And since this model is watertight, generating the major connector is not a problem, and everything has been blocked quite nicely. Then, after having these elements together, we can jump to the sculpting stage. And now software will basically recalculate my sculpting. What you see right now is one of the improvements of Dental System 2025. Although software is calculating and basically reapplying my waxing up, the model is not frozen. The screen is not let's say in pause, so you can actually see how it's changing. Since I'm still in the Sculpt toolkit, you can see that it's a simple wax knife that I have added material to make it look a little bit more like a gingiva. Of course, it's up to you how you would like to finish it, but it's a rather large radius and rather large level of material that I'm adding. It looks quite flat, so that I'm switching from adding to removing to create the chamfering in here. This one is overhanging a little bit, but it's just a matter of going back one step, pulling the molar a little bit more inwards to get the better results. So yeah, initially it looks quite flat. If I will switch it to minus, then we can make a nicer separations, make a better imitation of root eminence in here. And that's, I would say, the major difference between designing the secondary structure out of RPD and not the dentures, because this is the part that you would have to spend a couple of minutes to make it look a little bit more natural. And probably in here, the gingiva tool from the denture module will have an advantage. It's going to look a little bit better. All right, and once this part is done, we can quite simply further. We have another, let's say, sculpting in here if necessary. We can also sculpt on anatomy if you forgot to do it earlier on. And there's one more thing that it's worth mentioning. In here, I didn't load the additional file with the implant positions. So if you would have an idea of, let's say, creating the secondary structure with the screw holes, of course, we would have to have this information through. I'll show you where to find the file that could be loaded as additional files. And if some of you haven't tried it, in this option in here on the right with additional scans, we can load scans, and we can load, I think, more than 20 additional scans. So the information from the original bar design, I could load as an additional scan to get the screw hole information, and then probably use the attachment option in here with attach parametric shapes and cylinder hole. And once those additional scans will be visible in here as screw holes, I could use the parametric shapes in cylinder hole, probably from viewing direction, because then I look at the screw hole from the top and apply it in the right place. Why this element? Well, quite simply, it's very flexible. So it moves the radius by 0.1 millimeter increments. And then we can make it longer and choose what kind of depth we would like to do. Again, ensuring that it will basically go right through and create a screw hole here. Access if it's necessary. So yeah, that's also one thing to keep in mind. Another thing that is worth mentioning, like I said, this right now is separate file. As you can see, they are not in the same color. So how would I save a case like this for production? If we select save, choose our base model, and then I've clicked on the control to add the teeth. Right now, we have all of those as a file. And if I'll click Save Model, I can choose it to be an STL or PLY or DCM. Give it a put it on a desktop, save it, and now I will have a single STL file of my secondary element having a gingiva and full contour teeth all as one. Yeah, and that would be pretty much it when it comes to design of a secondary structure in that way. Okay. I can see that we have some questions. I would like you to submit them in writing, if possible, in the chat option or Q&A, and I'll get back to those a little bit later on. Okay, there's also the other bar that I have made. This one is a little bit simpler in the design. So for this, I just used a simple tapered shape for it. So I'll just quickly go through it to show you the differences and to show you cutting, which I didn't show you on the earlier one. So in here, the shape of the bar will be quite similar. And this particular one, you can see that it's quite tall. And I'm pretty sure that some of you seeing a design that long would be skeptical if it's possible to even cut it back. But as you can see, with the option to sculpt it, it's possible to select the distance. And in this case, software cut it directly to the gingiva, putting it together. So again, putting it through the model builder, it's possible to merge one object with another. Of course, adding it a base through the model builder, it will cover the screw holes, but it will also give it a base, which makes it very easy to design a denture afterwards, because software will not not have any difficulties designing a denture. So about the denture part, I will go back for a second to the order form. In here, it is I've selected in here a monoblock because this one, I mean, sure, we could use different modules, but in here, most likely you will be combining. There's no need to create a separate elements. creating coupling mechanism, most likely there will be no space for it anyway. So we can just directly go to the monoblock, especially that those usually give the most flexibility in terms of design for the teeth anatomies. Keep in mind that denture libraries are different to the fixed restorations, and some of the libraries might be a little bit more restrictive in terms of which files can be exported as an open STL file. So that's how it looks. And if we'll just go through the redesign option. Like I said, I have in this particular file, I have created, and I'll get back to this one at the end of the design, just to show you where to place the wax rim file before you will start. In this case, as you can see, there's also an information about the implants that was carried over. Since it's possible to design a denture over implants, this information is being carried away automatically. So in here, if we will have to create a screw hole access, those will be visible throughout the whole design process until the very end. Initial stages don't really change in here. And here I can also show you that the scans that were saved from the initial design, so preparation scan, bar, and antagonist, are placed in here as a wax rim file. And wax rim file is necessary for using a denture module, because this one allows us to define the occlusal plane. In here we can initialize it from placing it on the bar. If you would prefer, you can just rename the bar element, of course, from the DCM file, because it will keep the orientation in 3D as a wax rim, and then place it in a miscellaneous folder, and it will serve a similar purpose. Then we will set up the characteristic points exactly as they should for any other denture. And then we will draw the outline of the denture base, in this case, so our secondary structure. If you would like to bring it closer to the bar, that's of course possible. It might be a bit distressing that the bar in here is not coming with the same color, but that's not something that I would worry just yet. And what you will usually notice that determining the creating the gingiva might give a little bit different results if the model is not watertight. Okay, then we have a standard wax blocking, and then setting up the teeth through the Smile Composer. In here, like I said, very important will be to select the library for the teeth that are enabled, or they are allowing for designing denture. Usually at the beginning of the designing process, if you select, in here, if you will be switching between the different libraries, if there is the one that will not be compatible, software will let you know that the results are not going to be the way you expect. So I chose one of the Fabulous Smiles because those are pretty open, and we can use them for different types of the restorations, and of course they can also be scaled. One of the options that it would be beneficial for me is to be able to do morphing on the design. I have it disabled in the control panel because not every, let's say, library allows for that or should be allowed. So when designing a traditional denture, if we are planning on using carded teeth or pre-manufactured teeth, the last option in here shouldn't be visible, but that's an option that it's enabled or disabled in control panel. I have disabled it because I had a denture software training. So if somebody needs to use a carded teeth, scaling should not be possible. And in here, that's why it's also disabled in here. But if you will enable it through the control panel, it's also going to be visible in here. And then we are just drawing the outline exactly where we are planning it to be. And software will basically create the gingiva exactly where it was planned. As you can see, the axis for the screw holes are still here. And of course, we can use the gingiva tools with different styles, which makes it nicer. So in here, on a maxilla base, we have different gingiva aesthetics that we can select. We can choose the base thickness and relief. Relief in here, of course, serves as a spacer between the elements. So if you need to drop it down lower, sure, you can do that and choose an option for the denture base that will suit your style the most. Then we have an option again to sculpt on a denture base, and since we have, like I said, like we have earlier on, the option to put parametric shapes. If I will look at this screw hole, if I will need to use it, I'll place my attachment, match the size, match the angle of it, and quite simply just place the attachment in here. But there's some things that we can't guarantee. And one of the things that we can't guarantee is that this hole as small as this one will be millable in your milling machine. So that's something that might be a bit tricky, especially if the screw hole is small. I would say that 1 millimeter tool will not, or the CAM software will not allow 1 millimeter tool to access this hole and mill it. If you have access to a smaller drills, they might be able to go through this element. So click apply. It should be going through. Okay, and then it's a matter of saving element. Right now they are still separated, but once the software will calculate them both, you will see that they are placed together. As one object. All right, so this obviously will come as a one file, and as you can see, it also creates a space, creates a pocket for the for the bar. So that should go over our primary design. If you would like to have it narrower, sure, that's absolutely fine. If you will have difficulties creating the holes right through this design, you can see that they are still enabled in here. So we could just import it as the other object and just use those screw holes afterwards. But again, I'm a bit skeptical when it comes to milling the secondary object like this, as those screw holes are very narrow, and as far as CAM software will not be too happy to allow drills going through such a narrow holes. Okay, I'm leaving 5 minutes for a Q&A session. Of course, we can stretch it a little bit longer if necessary. So I will ask my colleague to maybe gather some questions and check them out. I will close my order, and just quickly before we will get to those, I promised one more thing. So I promised to show where to place the wax rim file. So if I will go to option that it's called Explore Order, this is basically the directory where the case is being saved. And in here we have all of the data. So the moment the order form is being created, the files are already placed, especially when we do the copy and append. And here in the scans folder, from the initial order, we will have upper and lower folders created. And in this miscellaneous folder, as you can see, I have placed the wax rim file, and that's the one that was basically saved from the first one. Do you have to do it like this? Probably not. If you would just take the bar design, name it the wax rim as a DCM file and place it over here, that will be enough. So basically the denture module will be looking for this folder and the file that it's named exactly like this. All right. So I could see some hands being raised in the process, so I assume that there are some questions.
Yes, Christopher, there are lots of questions, and thank you so much for your time and for this webinar. So I will read it one by one, and hopefully
Absolutely.
we can get everyone involved. What about spacer between bar and zirconia? That was the question.
Sure. So there are, usually that depends on the secondary structure. So for both denture and for RPD, there's usually some spacing in between those elements. They are usually predefined, and those are being applied by default. If you're reducing it to minimum, there's still an option for the blockout wax, and blockout wax can be defined pretty precisely. So if there's not enough space from your initial design, I mean, in here, it will require some testing. Each one of you will have different machines. Each one of you will use slightly different materials, and you will be probably centering your zirconia with a slightly different parameters. So in here, I would strongly recommend to make a couple of tests, but the spacing can be adjusted either with the regular relief zone, and if just a basic relief zone is not enough, there's possibility to use a wax knife on the blockout wax stage, for instance, to give a little bit extra spacing if necessary.
Thank you, Christopher. And I see lots of people are raising hands, so please write down your questions so that we can answer them. Thank you. Another question. A lot of time when adapt the bar to gingiva, the software freeze, and we need to close that design. Do you have any solution or advice?
In here, the difficulty that I have experienced with this type of a behavior, first, happened quite some time ago. So it didn't happen on the latest version of the software. And as you can see, I tried the software quite extensively. And the difficulties that I have experienced is usually on the models that are not watertight. That's why on the initial design, on both cases, that I went with the case through the model builder to give it a thickness. Blocking out wax will also, let's say, make sure that it's stable. And in here, I have a feeling, and it might be just a gut feeling, that you're not using either 2024 or 2025 software. Because on those two versions, we've made quite a lot of changes and improvements on the stability of the denture base. So that would be my two main things: making sure that you work at least on 2024 software and working on the watertight models.
Show us, please, how to add the holes on this denture.
So when it comes to the holes, that was, I believe, at the end that I showed, that was using the attachments. If your holes will be going through the teeth, that might be tricky to attach. But this file at the end can be re-uploaded. I would say as a, how would you put it? You can import it as a wax up coping, and then basically make holes into it using that if necessary. But again, I'm a bit skeptical if the milling machine will mill them.
Thank you. Very good design tips, Christopher. I think we answered all questions, but let's maybe leave like maybe 3 minutes in case someone will.
Yeah, absolutely. I'm here for you. So what we can do is, we will be here, and let's make it like this. We will keep the session open for another, let's say, 15 minutes. So even if there will be no questions arriving, or somebody is a little bit shy on asking a question and getting the answer in public, what we can do is you can submit those questions, like I said, within the next 15 minutes, and we will address them directly if you registered with the correct email address. Otherwise, it's obviously going to be tricky for us to reach you. And there's one more thing that I think is worth mentioning. After this session, again, if you use the real email address, you might receive a link to a survey, so you can evaluate this webinar and give us a feedback. So I think that's the best that we can do for now.
Yeah, but that would be great. But I see already 3 more questions, so let's just answer them.
That's good.
Hello, and thank you for the presentation. If there are any way to split one STL to hybrid and bar, or you should create the bar alone as you present.
So I've showed you the current solution, and of course the software is evolving. I had a conversation with say people that are responsible for the development of the software, and I was asking them exactly the same question. That is a question that pops up very, very frequently, quite frankly, because of the offerings from Blender and Exocad. So the information that I can give you right now is that we are looking into such option. Yes, it would be nice to have it, but right now, from what I can see, the control of the spacing between those two is quite uniform. And if we will create such option, I would really like to see a little bit more customization here. So not just splitting it with 0 distance, because that's not always the best option for manufacturing. And that also might bring difficulties on the later stage, not necessarily on the initial fit. But keep in mind that, especially when we're talking about titanium base and zirconia superstructure, those materials will expand and contract at the different pace. So in here, I'm really curious to see how these cases will behave how will be the longevity of them. Because if patients will be eating ice cream, drinking coffee, or the worst case scenario, doing both at the same time, that might cause quite a lot of stress on the cases like this. So I'm curious to see how that will behave, and if the cases split it with a 0 gap in between, how they will basically stand the test of time.
And I think last questions.
Sure.
For opening the webinar. Is there any way to do a substructure bar and final restoration in the same time with Exocad now offering?
I think that kind of reflects to what I've just said, that we are looking into such option. At the moment, we're using two separate orders, and speaking with some of the labs and getting a feedback from them, I know that it's, let's say, it gets very inspiring when you see how easy it can be done. But I came across the labs that are, let's say, deliberately using and prefer two separate orders, because the first order very often gets sent to the clinic to do initial test fit. And if that one looks okay, sometimes it's being, let's say, rescanned with additional layer of sort of opacker that is trying to cover the shape, the shade of the metal or the color of the metal, and then the secondary structure is added on top of it after rescanning it in the lab. So there's multiple aspects to it. We are, let's say, in the position when we are looking into adapting the software to splitting the file, but it needs to be done in a wise way, so it can fit every time, and like I said, stand also the test of time.
Thank you, Christopher. So I guess for now we answered all the questions, but like I said, we'll have
yes. So what we will do is, we will stop sharing our faces and the voices and the screen, but we will not close the session for another couple of minutes. So if you would like to submit the question and get answer in